So let's start with variability. Well, this is a picture that you may have a lot of pictures in your fields like this, where you see very clearly variability within the fields. And this comprises different factors, different limiting factors that affect the growth and yield of crops. And this may vary from region to region. And this is a research from the INTA, the Argentine Research Institution in the Pampas, where they, in different types of crops, in different type of management zones, and here it's divided a little bit by topography. The sandy high, the high, medium, low, hydric low, saline low. So having characterized a field in those type of areas or environmental zones, we'll have a different crop response. Then we have the causes that we can find for potential variability. This can be very, very, we can have different causes. We can go from soil types, positioning in the landscape, drainage issues, soil depth, water logging, irrigation scheduling. So you have a different type of causes that can cause variability. The main concept is that different zones will lead to differential management. So we have environmental variability, where we can identify those factors that cause variability. So we know in our area, we know by visiting our fields, what are the main factors that are limiting our yield potential, or crop growth, I would say. And then the second aspect is to identify and limit productive zones. Based on that environmental variability, we'll have differential management, where we'll see, based on what are the limiting factors, what type of rules will we apply for managing crops by zone. And this leads to increased productivity and more efficiency. So this has a number of benefits: increase efficiency in the use of crop inputs, avoid undesired environmental effects, and of course improve the bottom line, the economic returns. So that's it's very obvious, but this is a nice logical framework where we go from variability to management. Francis was just telling me it's all about management, really, and he'll develop that in more detail, that concept in more detail, and that leads us to increased productivity. So that's why it's so important. It's the difference between winning and losing, between making a sustainable production or not, to identify variability and have a corresponding differential management criteria. So the next question, after we understand why is it so important, is how do we recognize that variability? So here, these two slides show that what we see in the field as things that look, or areas that look different, this can then be mapped as two different zones, and use GPS to see where we are and take decisions accordingly. So we have different tools for recognizing variabilities. Of course, productivity maps, which is the topic of the day. And then you have other methods as well, such as electrical conductivity, such as yield maps, such as taking samples in grid. So that's an agronomic discussion about the merits, benefits, advantages, disadvantages of each method. So this is a typical grid sampling and interpolated maps, which is very popular in the Midwest, in the US, and in Brazil, as I found. So here, basically, it's setting up a grid of points every hectare, every 2 hectares, and then taking those soil samples, taking them to the lab, and then creating interpolated maps. Another way to see the variability within fields, and most farmers nowadays are equipped with yield monitors. I mean, most commercial mid-large farmers are. All the new equipment comes with yield monitors, so it's always very useful to map those yields. Here we see barley, and we see a range from less than 4 up to maybe around 8 tons per hectare in this map. And the productivity map, which is the topic of the day, which divides the field in classes from a very low yield to very high yield in blue. And we'll see how this is generated. So basically, those are 3 methods where we recognize variability. and we'll see why and how we use productivity maps.